Welcome to the World Engineering Day Hackathon wrap-up show. I'm Marlene Kanga, former president of WFEO, and I led the successful proposal for UNESCO to declare March 4th as World Engineering Day for Sustainable Development. Since 2020, I'm proud to have been a member of the working group that has organized the World Engineering Day celebrations, including the hackathon with its focus on young engineers.
Hi, I'm Tanil Sakluna, owner of The Big Creative. Each year, we co-create and produce this prestigious World Engineering Day Hackathon program.
We're here to reveal the submissions from our top 15 finalists and introduce our incredible hackathon judges, including me.
This year has been our biggest hackathon yet, with over 3,000 engineering students from over 90 countries registered to take part. This was definitely the largest turnout we've ever had. I've been involved in hackathons for over 7 years now, and this is officially the biggest registration number that I've ever seen. We received over 140 incredible entries from our teams hacking SDG 1, No Poverty. It's clear to see that young people today are really committed to solving global challenges. Seeing the passion and innovation from the next generation of engineers has been really inspiring.
Well, Tanil, what an incredible result for the 2025 World Engineering Day Hackathon. The passion and dedication we've seen from these young engineers is truly inspiring. It gives me great confidence that they have what it takes to tackle the engineering challenges of the future. The global engineering community is clearly moving in the right direction. And now, it's my great pleasure to introduce our 2025 Hackathon judges.
Hi, I'm Alexei. I'm a doctor of engineering, heading a laboratory at the United Nations University. I'm glad and honored to be one of the judges for the World Engineering Day Hackathon. Good luck!
Ladies and gentlemen, dear participants on the World Engineering Day Hackathon 2025, it's my pleasure to be one of the judges of this phenomenal event. My name is Rodrigo Pérez Fernández. I am professor in the Technical University of Madrid, Universidad Politécnica de Madrid. I am expert in the field of the marine engineering and architecture. So thank you very much, and I expect the best of you. Thank you very much.
Hi, I'm Jessica Mansami, Senior Associate Civil Engineer at Mount McDonald. I'm really excited to be back as a judge for the World Engineering Day Hackathon 2025.
Hi, my name is Li Huixu from International Center for Engineering Education at Tsinghua University. I'm a judge for World Engineering Day 2025 Hackathon.
Hello, I'm Ramon Manresa, industrial engineer from Spain, and Anna Jabs in the World Engineering Day Hackathon 2025.
Hi everyone, I am Habibi Razak, Regional Director, Global Energy for Surbanajuram Group based in Indonesia. Would like to say hi to all engineers all over the world. Happy World Engineering Day 2025. I am one of the judges for this World Engineering Day Hackathon 2025. Would like to congratulate to all the panelists who have made it into this competition. Have a great World Engineering Day. Thank you.
Hello, my name is Valeria Starshaya and I'm a judge of 2025 World Engineering Day Hackathon.
Hello everyone, I'm Prashant Atmakuri, working as an assistant professor at Prasad B. Potluri Siddhartha Institute of Technology in India, and I'm honored to be a judge in the preliminary round for the World Engineering Day Hackathon 2025, which is an initiative brought by the World Federation of Engineering Organizations in partnership with UNESCO and Engineers Without Borders International. This event is a testimonial to the incredible creativity, innovation, and dedication of students from around the world. In this hackathon, students have tackled some of the world's most pressing challenges by developing groundbreaking engineering solutions. From sustainable energy to cutting-edge technology, their projects showcase the power of young minds to shape the future. As a judge, I am excited to review these remarkable projects and witness the brilliance and inventiveness of our next generation of engineers. Each project reflects the passion and hard work of the students, and I am thrilled to see their ideas come to life. I congratulate all the participants, mentors, and organizers for making this event a success. Let's continue to celebrate and support the innovative spirit of our youth. Together we can engineer a better tomorrow. Thank you.
My university. It's a great honor for us to participate in such event as a hackathon, where young minds come together to share their best ideas to make our lives better. The strongest will prevail. Go science, go engineering.
I'm Nahla Al-Qasimi, Associate Professor in the Town Planning and Dean of Students at Ajman University. I'm the Vice President of Society of Engineers, United Arab Emirates, and Executive Council member at the WFO. I'm thrilled to have served as a judge for the World Engineering Day Hackathon 2025, this initiative that empowers future engineers to tackle global challenges through innovation, where young engineers showcase their innovative solutions aligned with the UN Sustainable Development Goals. Witnessing their creativity, dedication, and problem-solving skills was truly inspiring.
Good day, everyone, from Sydney, Australia. My name is Dr. Marlene Kanga, and I'm a former president of the World Federation of Engineering Organizations, serving in this position from 2017 to 2019. I'm very proud and pleased to be a judge of the finalist of the 2025 World Engineering Day Hackathons. I'm looking forward to seeing the innovative solutions from young engineers around the world and how they can make a contribution to advancing the United Nations Sustainable Development Goals. Good luck.
Hello everyone, I'm Firas Boudiab, a civil engineer specialized in transportation and infrastructure and an advocate for sustainable engineering. I'm honored today and excited to be one of the finalist judges for the World Engineering Day Hackathon, where young engineers and students from around the world are showcasing groundbreaking solutions to global challenges. This hackathon is a testament to the power of engineering in driving sustainable development, and I'm really excited to witness the creativity and the impact of the finalists' ideas. Best of luck to all participants. Your innovations are shaping the future. Thank you.
Hi there, my name is Katie Cresswell Maynard. I'm the Executive Director of Engineers Without Borders International, and I have the great honour this year of being one of the few people that get to judge the final 15 hackathon student entries. And I am so excited to be part of this initiative. Hope that all the students that have participated have had a great time, really enjoyed tackling the challenges that we put in front of you, found it really interesting. And more than anything, I really hope that you're all inspired to think of engineering a little bit differently in future.
Hello everybody, I am Platon Astilianou, President of the European Council of Civil Engineers, and I'm very glad to be one of the international judges for the WET 2025.
Each year, we select UN Sustainable Development Goals to highlight for the hackathon. This year, our participants hacked SDG 1, End Poverty, in all its forms everywhere. The teams were set 3 challenges based on real-world issues relating to poverty. To help you understand what the teams were working on, I thought I would give you a brief summary of each of the unique challenges. Challenge 1. Improving the climate resilience of subsistence farming. The climate crisis is already affecting the weather patterns that many communities have relied upon for centuries to grow their crops and feed their animals, increasing vulnerability of food security and deepening poverty. Extreme weather events such as droughts, flooding, and heat waves are becoming more frequent and severe. Likewise, as the climate changes, so do the pests and diseases that attack crops and livestock. The World Bank estimates that climate change could push an additional 132 million people into extreme poverty by 2030, with smallhold farmers among the most affected. So for Challenge 1, teams were tasked with supporting the communities most vulnerable to the impacts of climate change to maintain sustainable food production. Challenge 2, addressing informal housing and infrastructure challenges in urban areas. As urban populations continue to grow, informal housing, sometimes referred to as slums, have become a prevalent issue in many cities worldwide. Currently, over 1 billion people live in informal settlements, a number that's projected to increase significantly by 2030. 85% of people living in informal settlements live in just 3 regions. 359 million live in Central and Southern Asia, 306 million in Eastern and Southeastern Asia, and 230 million in Sub-Saharan Africa. The rapid influx into urban areas is driven by economic opportunities, but it often outpaces the capacity of cities to provide adequate housing and essential services. Informal growth is often disconnected from a city's main urban infrastructure, such as transportation, water, electricity, and waste management, resulting in poor health and economic outcomes. So for Challenge 2, we asked teams to come up with ways to improve the quality of life and increase the resilience of communities living in informal settlements. Challenge 3, empowering women to overcome poverty through digital technologies. Approximately 1 in every 10 women around the world lives in extreme poverty. Access to education, healthcare, and economic opportunities is often limited, and gender inequality is deeply entrenched, exacerbated by cultural norms and systemic barriers that limit women's opportunities and access to financial services, employment, health, education, and decision-making roles. Increased access to digital tools and services provides transformative opportunities for women through access to information, education, healthcare, and networking opportunities. Year on year, the number of internet users around the world continues to grow, and mobile phones are the primary and often only way people get online. However, women are less likely than men to own a mobile phone. So for Challenge 3, we asked teams to design digital empowerment tools that will transform the lives of women living in poverty.
Thank you, Marlene. What a great overview. So today, we're actually going to give you a small snippet at all of the top 15 finalists. To watch the full submission for every finalist, please head to worldengineeringday.net where you can stream and view all of the top 15 there. Now, I'm proud to present our first finalist from the 2025 World Engineering Day Hackathon. Representing the University of Twente in the Netherlands, this team's tackling Challenge 2, addressing informal housing and infrastructure challenges in urban areas, with their innovative solution, the manufacturing box.
With over 1 billion people living in substandard housing, many lack access to proper sanitation facilities, impacting their health, dignity, and safety. At the same time, plastic waste piles up, clogging waterways and polluting communities. But what if we could turn this plastic waste into opportunity and contribute to the challenge of access to affordable housing?
Introducing the Manufacturing Box, a self-sustaining microfactory that converts plastic waste into building bricks, thereby supporting communities in creating jobs, bricks to build houses, and reducing plastic waste simultaneously. The cleaned plastic shreds get melted and mixed together. This mixture will be molded into bricks using compression molding. The entire system runs on solar energy.
Using CAD software, the bricks have been carefully designed to use as little plastic as possible. Only 1.3 kilograms of plastic waste per brick. The bricks are manufactured using low-cost and low-tech machinery and laser-cut molds, suitable for the solar-powered shipping container factories. Through compression molding simulations, we optimize the production process, ensuring that every brick is efficiently molded with minimal material waste. The interlocking design of the bricks allows for a quick and easy building process, which has been tested using 3D printed prototypes. The manufacturing box also has gone through various iterations and manufacturing simulations, enabling a high throughput of only 4 minutes per brick.
The bricks produced in the manufacturing box can be used for proper housing in informal settlements or build washrooms for schools in the local communities. And with this, provide education on the value of waste and create better sanitation.
What an incredible solution! Next up, let's check out the submission from Team Hustlers, a talented team from Pakistan with members from the National University of Science and Technology, Islamabad, and Abdul Wadi Khan University, Mardan. They've also taken on Challenge 2, addressing informal housing and infrastructure challenges in urban areas. Let's watch.
The biggest issue with the housing in the urban area is the use of inefficient and heavy building material, that is clay bricks and concrete blocks. These types of material increase the loads on the building, making them vulnerable to the seismic activities. It also leads to the high construction costs and energy inefficiencies. Our challenge is to replace these types of material with something that is not only safer and lighter, but is more energy efficient and cost effective.
Today, we talk about CLC concrete or cellular lightweight concrete.
The lightweight concrete is an innovative material that is made by introducing air bubbles into concrete mix using foaming agent. This creates a lighter material, around 50% lighter than conventional concrete. Because of its reduced weight, CLC can be used with less reinforcement and lighter foundations, reducing the construction cost up to 25%. This makes it an ideal material for use in low-budget housing schemes and in regions with limited construction budget.
CLC's air-entrained voids create a unique balance of strength and lightness, and we can use mathematical models to predict its behavior under different loading conditions, including seismic forces. These models help engineers design buildings that are not only strong and safe, but also efficient in terms of material usage. Through advanced mathematical simulations and calculations, we can further refine the mixed design of CLC, adjusting the perfect balance between cost, strength, and insulation properties.
An example of prototype of such construction is this. This is a single lightweight concrete structures and that have been built on the specific research, and it is implemented in different urban and rural areas of Pakistan.
Wow, Marlene, what a spectacular submission. The quality of these solutions is really, really impressive. Next up, we have the Smart Irrigation Monitoring System from Team Torpedo. This team comes from PSB Academy in Singapore in partnership with the University of Hertfordshire. They're tackling Challenge 1, enhancing the climate resilience and sustainability of subsistence farming practices. Let's take a look.
Climate change has made subsistence farming increasingly challenging, leaving small-scale farmers vulnerable to unpredictable weather patterns. Crops fail due to insufficient water during droughts or excess water during floods, further trapping farmers in a cycle of poverty. To tackle this, we present our innovative solution, the Smart Irrigation Monitoring System, which helps farmers with affordable technology to enhance climate resilience and protect their crops.
Since a low-cost, user-friendly system that works seamlessly to optimize water usage to the crops. Solar-powered soil moisture sensor continuously monitors the soil conditions, that is powered by mini solar power units, making it sustainable. The system contains GSM module which sends real-time data as an SMS to the farmer's mobile phone, ensuring the functionality is even accessible without internet access. The solar power unit collects the energy from the sun and it gives the power to the moisture sensor, which collects the moisture from the soil. Then this moisture data is transmitted to the GSM module, and this GSM module gives a notification to the mobile phone, which will be used by the farmer.
Artificial intelligence enhances SIMs with smart applications. Predictive analysis: AI analyzes historical weather patterns and sensor data to forecast future irrigation requirements. Adaptive thresholds: the AI dynamically adjusts soil moisture levels based on crop type and upcoming weather conditions, making SIMs smarter over time. Community dashboard: an AI-powered app delivers pest warnings, planting tips, and community-specific insights, helping farmers make informed decisions.
SIMS is not just a solution, but a lifeline for small-scale farmers. By empowering them with affordable AI-driven technology, we can help them to build a resilient against climate change.
Well done, Team Torpedo, on what looks like a truly intelligent solution. Next up, we have Team Small Duckweed, Great Defender from China. The team hails from Tianjin Normal University and has taken on Challenge 1, enhancing the climate resilience and sustainability of subsistence farming practices. Let's check out what their submission is about.
Water is the source of life, yet approximately 2 billion people worldwide lack access to safe drinking water. However, cadmium, as one of the most toxic heavy metals to humans, presents significant challenges due to its persistence in the environment. Once released, cadmium resists degradation by recovery and readily accumulates in the food chain, posing severe threats to human health and ecological systems. What can we do? We choose bioremediation as a primary approach to address heavy metal cadmium pollution in aquatic environments. Duckweed, with its rapid growth, ease of cultivation, and broad distribution, is an excellent candidate for bioremediation. Our team has employed advanced techniques, including gene chip technology, genetic transformation, and real-time dynamic tracking of signaling molecules to comprehensively study the dynamic changes of signaling molecules in duckweed under cadmium stress. And we found glutamate is important for cadmium tolerance and accumulation. Therefore, we overexpressed the key enzyme related to glutamate metabolism, that is, PSAT. PSAT transgenic duckweed showed an enhanced cadmium enrichment capability. It increased cadmium accumulation by 119% compared to the wild-type duckweed.
This project not only provides critical technical support for heavy metal pollution remediation, but also paved the way for new applications of duckweed in environmental restoration.
This accomplishment not only provides critical technical support for heavy metal pollution remediation, but also paved the way for new applications of duckweed in environmental restorations.
Next up, Team InnovateHers from Ghana University of Mines and Technology. They're hacking Challenge 1, enhancing the climate resilience and sustainability of subsistence farming practices. Let's watch.
Unpredictable weather and a lack of reliable information significantly impacts agricultural productivity. Farmers face challenges in planning essential activities like planting, irrigation, and fertilizer application, often resulting in reduced crop yields and financial losses. As a result of this problem, our weather detection system is an innovative solution that provides real-time weather information and actionable insights. It leverages IoT technology to track essential weather parameters like temperature and humidity, and also provides personalized advice to support agricultural practices.
Once you've installed the device, it continuously tracks weather patterns and sends the real-time data of the weather to a mobile device using an ESP8266 module. Through these connections, the device interprets weather forecasts and suggests specific activities that are ideal for each day's conditions, such as watering the farm, protecting farms against heavy rainfall, and adjusting to potential frost or extreme heat. Our device reduces guesswork, saves resources, and increases productivity. We are really excited to bring this advancement to rural communities especially, where it can make a real difference, enhancing food security and supporting resilient farming practices.
Great job, Team Innovators. What a fascinating device. You should be incredibly proud of yourself. It's also fantastic to see so many women pursuing engineering, something we're all deeply passionate about here at World Engineering Day. Well done. Next up, we have the EcoShrimp Innovators, bringing us an exciting strategy for sustainable shrimp farming. This team, also from Tianjin Normal University in China, is tackling Challenge 1, enhancing the climate resilience and sustainability of subsistence farming practices. Let's take a look.
Shrimp is delicious,
and a key species in global aquaculture. It provides high-quality protein for people around the world. But there's a problem. Shrimp farming relied too much on antibiotics several years ago. But over time, bacteria become resistant. Plus, antibiotics accumulated in water, harming humans and the environment. So we are looking for a safer, sustainable alternative antimicrobial peptides. AMPs have a unique ability to kill bacteria. Unlike antibiotics, AMPs don't cause resistance. They are safer and more effective for shrimp health, and they don't harm the environment. We start by isolating the genes that produce AMPs. We focus on PAN3A, an AMP from white shrimp. Using genetic engineering, we transform these genes into plants and yeast to produce the AMPs in large quantities. Our main platform is genetically modified duckweed. Our tests show that the duckweed with PAN3A kills bacteria, including both gram-negative and gram-positive strains. The duckweed grows well in wastewater and helps keep the water clean. The yeast produced grostin 2 also works well to fight bacteria in the lab. Once we harvest the AMPs, we mix them into shrimp feed. This gives shrimp lateral protection against bacteria, reducing the need for antibiotics. Join us in creating a cleaner, healthier, and more sustainable future for aquaculture. Together, we can make a real difference.
Now we have Team York University from York University in Canada. They tackled Challenge 2, addressing informal housing and infrastructure challenges in urban areas.
Imagine a world where about 1 billion people live in makeshift homes lacking basic necessities like clean water and proper sanitation. It isn't fiction, it's the reality of informal settlements or slums that house nearly 1/3 of the urban population in developing countries.
Many residents lack access to clean water, proper sanitation and reliable electricity, making their daily life difficult and unsafe.
But what if we could empower these communities to build safer, more resilient homes? What if we could put the power of sustainable construction directly into their hands? This is where the AR Home Builder app comes in.
By leveraging augmented reality technologies, we are providing step-by-step guidance for constructing strong, affordable, long-term and sustainable housing solutions using locally sourced materials. Our app includes modules for water management, sanitation solutions and waste management. These features help residents implement systems for clean water access and proper sanitation, reducing health risks associated with poor infrastructure and increases resilience against environmental threats.
Our app is designed to be user-friendly and accessible to individuals with little or no prior building experience. It empowers users through clear instruction and visual aids, enabling them to take charge of their housing needs without relying solely on external builders and architects.
Our app offers a multilingual interface with voice instructions. You can select your location to access local climate data, land information, and supplier contacts. We consider the number of occupants to determine the ideal house size, preventing overcrowding. You can add team members to assign trackable tasks to each person.
We transform your blueprint into a 3D AR model which visualizes both the interior and exterior of the house at each construction stage and can be scaled and rotated for a better perspective. Our project management feature allows its generative AI to automatically assign tasks and provide safety tips to prevent accidents. Get support from professionals who can help you refine your blueprints and your models.
Users can learn how to use our app easily without construction knowledge and also learn various building techniques for their project and sustainability practice.
By making construction knowledge accessible and providing tools for community-led development, we are not just building houses, we're building hope, resilience, and a path out of poverty for millions.
What a great submission! It is amazing to see new technologies like AR being put to such an incredible use. Next up, Team EcoShrimp. They are coming to us from Batangas State University, the National Engineering University in the Philippines. They are hacking Challenge 1, enhancing the climate resilience and sustainability of subsistence farming practices.
Heart of the Philippines, farming is the lifeblood of many communities. But today, our farmers are facing a growing crisis.
Untreated wastewater from large piggeries and nearby agricultural facilities is contaminating water sources, making the soil unproductive.
Without fertile land, crop yields drop, and subsistence farmers are left struggling to survive.
But there is hope.
What if we can turn this challenge into an opportunity?
Our innovative solution starts with two natural materials, eelgrass and kaolinite clay.
By combining eelgrass biochar and kaolinite clay, we are making a phosphate-absorbing beads.
These beads are designed to remove excess phosphate from wastewater, transforming a harmful waste into a valuable resource.
By absorbing the phosphate from wastewater, they help to reduce environmental contamination while offering an innovative solution to waste management in the agricultural sector.
These biofertilizers, made from recovered phosphates, are a game changer for farmers. Unlike synthetic fertilizers, which are vulnerable for price fluctuations, biofertilizers are sustainable and cost-effective alternative. They not only improve soil fertility but also make crops more resilient to extreme weather conditions, which are crucial in an era of climate change.
And the hits just keep on coming. As the hackathon director, I can tell you that everyone in the top 15 really deserve to be here. Selecting the winners must be really difficult for our final judges. The next team also comes from the Philippines. This team comes from the Technological Institute of the Philippines in Manila. They're tackling Challenge 2, addressing informal housing and infrastructure challenges in urban areas. It's Project E-Cubo. Let's watch.
In our visit to Gawad Kalinga, nakita namin yung mga real-world problems doon na nagkakaroon ng shortage sa tubig or sa electricity, na to the point na nag-share sila ng resources na yun, which is not ideal. Sa project namin, gusto namin na mabigay yung housing na deserve ng isang pamilya, which is meron siyang sariling tubig at meron din siyang sariling electricity.
Our project is entitled Project E-Cubo, which means economical, cube shape, and modern Filipino design bahay kubo inspired house. This project came from the inspiration of a Rubik's Cube. So this Rubik's Cube has, as we can see, a rigid form, and with that aspect, we think of an innovation that can build apart from an existing type of technology or methodology of construction.
This project E-Cubo gives us an innovative solution by having a wall system design that offers a pre-fabricated concrete panels that has an interlocking and stackable design.
We think of an innovation about an interlocking design as also a stackable part on the vertical part of the block in order to resist the forces of the blocks, and the interlocking will also resist the horizontal forces with an integration of a rebar wall stiffener on the part of the interlocking design. The design reflects the needs of the communities by having a space-saver interior design, an interlocking stackable blocks which can help reduce the cost of blocks by having a hollow core design on it, and also a time-efficient construction method wherein it can build faster compared to a traditional construction method.
Through advocating this approach, we aim to encourage families to thrive rather than just survive.
What a wonderful solution. This is my 4th time hosting from the World Engineering Day studio, and I'm really honored to be able to take you through this really powerful series of hackathon submissions. And now we're up to submission 10 with a solution for global housing. They're a truly global team made up from members from the University of New South Wales in Australia, the American University of Sharjah in the United Arab Emirates, and Dedan Kinabi University of Technology in Kenya.
Over 1 billion people currently live in informal settlements facing critical challenges for inadequate housing and waste management. These challenges not only exacerbate poverty but also threaten health and environmental sustainability. It's understood that over 70% of waste in slums remains uncollected. Poor waste management causes water pollution, blocked drainage, and disease outbreaks like cholera and malaria. The WHO estimates that uncollected waste contributes to around 9 million premature deaths annually due to poor sanitation.
Our solution is smart community bins that sorts waste into different categories like organic waste, e-waste, textiles, construction waste, and plastic. This can be done using technologies like AI systems, cameras, sensors, and computer vision-based image recognition. The bin will be integrated with IoT devices to notify local authorities when the bin is full to ensure timely collection. After the waste has been collected, it will be taken to recycling centers where it will be converted into essential amenities that can be distributed to poor people. This creates a circular economy by turning waste into resources. Our solutions also provide economic incentives to poor people and promotes community engagement. Residents earn small payments for every item deposited in the bin, encouraging people to dispose of garbage in dustbins and providing daily financial support for low-income families.
Firstly, we begin with the pilot phase where we deploy around 50 smart bins in medium-sized areas, train the locals with the technology, and also build small-scale recycling centres for the plastic bricks and the composting. Further, we work with the community by creating awareness through visual guides and community workshops on the incentives in the recycling program. Then we scale this up to deploy 1,000 bins across different slums and work with local governments as well as expand these recycling centres to increase capacity. Finally, we use data analytics of IoT and AI to optimize bin placement and waste collection, as well as publish annual reports for more funding and further expansion. Our solution not only addresses the waste crisis in informal settlements, but also transforms these communities into hubs of innovation and sustainability. By turning waste into resources, we can better housing, improve livelihoods, and align with global climate goals.
Speaking of global reach, we have over 90 countries participating in this year's competition. Truly amazing. Next up, we have Empower from the National University of Singapore, tackling Challenge 3, empowering women to overcome poverty through digital technologies. Let's watch.
Today we are introducing a digital platform that helps women in poverty in low-income areas of Southeast Asia. Many women here face barriers that keep them in poverty. One of the most significant reasons is that traditional gender roles often limit them to unpaid domestic work. Fortunately, internet connectivity in Southeast Asia has improved a lot in recent years. Plus, we know that many women here possess traditional craft skills. They make products which are valued in global markets for their cultural significance and sustainable qualities. Thus, we propose a digital platform that integrates online education, skill exchange, and an e-commerce credit system.
The education system is designed to empower women and girls, breaking the cycle of poverty. For adults, we offer practical skills training, such as in-house farming and digital literacy.
Through our platform, women can exchange skills, learn traditional handcraft techniques, and access life-changing opportunities. Not only can you build your knowledge, you can also earn by sharing your handcraft creations in the marketplace. Skills are divided into two main categories: handicraft like weaving, jewelry making, and also life skills like cooking and gardening. Each skill comes with a dedicated resources and tutorial section filled with easy-to-follow instructional videos and printable guides that you can use anytime, anywhere. Users can upload their own tutorial videos to earn e-credits on the website after passing the certification exam. These resources ensure every woman has the tools she needs to grow at her own pace.
This platform will enable women to gain knowledge, earn income, and share their unique skills, helping them break the cycle of poverty and build better futures.
Next up, we have CH Minions Hacking Challenge 2, addressing informal housing and infrastructure challenges in urban areas. This team comes to us from the STI Myanmar University.
Today, over 1 billion people worldwide still live in informal settlements with limited housing options and infrastructure.
Our country, Myanmar, has faced a huge increase in poverty in recent years. The percentage of the population in poverty has doubled from 2017 to 2023, including almost half of the citizens in the last few years.
With the increase of climate disaster nowadays, our country, Myanmar, faced typhoon Yagi in 2024, resulting in 236 deaths from massive flooding. 730,000 people needed help. So, our solution aims to solve this issue, providing a safe and affordable place to stay while integrating flood adaptation measures and create a hard length strategy for modular scalable housing response.
So firstly, our monitoring system will collect data from meteorological stations, satellites, and sensors placed at rivers and dams like Lake Reservoir. In case of emergency, the system will send an immediate alert, and the control center of an area, for example, a government district office, will receive the message. Then they're gonna warn the residents using the solar-powered building alarm system of the house, which can still function even when the power is out. During the flooding, the floor of our house will rise up with the water level using the buoyant property of recycled plastic bottles stuffed inside the floor. In this way, we can prevent property damage and losses from flooding, which can cause a huge impact on the residents. It's also designed to be taller than ordinary houses for safety, and a ceiling window is installed for emergency escape from the roof. Besides, the wall panels submerged in the flood will open up for the water to flow through quickly, which can reduce the rise of flood waters.
Together, we can make sure that no one is left behind.
Along with our solution, we believe that we can fight poverty, inequality, and lack of preparedness for natural disaster all at once, bringing safety, security, and better quality of life to our citizens in informal settlements.
Now we have another team from Batangas State University in the Philippines. It's Team Pathfinders. They're hacking Challenge 2, addressing informal housing and infrastructure challenges in urban areas. Let's watch.
Approximately 2.01 billion tons of municipal solid waste were generated globally in 2016. 353 million tons of plastic waste were generated in 2019, with only 9% being recycled. Traditional methods of waste management are not only inefficient but also detrimental to our environment. How might we help people in a better way to manage their waste, one that reduces landfill use and minimizes environmental impact?
Introducing the Solar Bin. It is a sustainable, organic, low-impact, automated recycling bin. The Solar Bin is designed to revolutionize waste management by accelerating the decomposition of organic waste.
Users place their organic waste, such as food scrap and yard waste, into the chamber. Second is the heating mechanism. Once the waste is added, the solar panels automatically activate the heater. The temperature within the chamber rises to an optimal level to facilitate the decomposition process. Third is the decomposition process. Over a period of weeks, the elevated temperature and the controlled environment inside the chamber cause the waste to break down into nutrient-rich compost. This accelerated decomposition not only happened faster compared to traditional composting methods, but also helped minimize odors and the presence of pests that are often associated with open-air composting. The key advantages of this decomposition process are that it is faster and more efficient than the traditional composting methods, while also reducing undesirable byproducts like odors and pests. The combination of the controlled heating and the breakdown of the organic matter result in a high-quality compost that can be used to enrich soil and support plant growth.
The solar bin represents a significant step toward a more sustainable future. By embracing innovative technologies and community involvement, we can tackle the waste crisis head-on. We invite you to join us in this initiative, support sustainable practices, and help create a cleaner, greener planet for future generations.
Once again, we are back with another team from Batangas State University in the Philippines. Congratulations to that university with a whopping 3 teams in the finals.
Wow.
Here are Team ASINderos, tackling farming in coastal regions with their solution to Challenge 1, enhancing the climate resilience and sustainability of subsistence farming practices.
Food shortage kung magpatuloy no way to earn a living to feed.
Bitin kapag walang-wala na sa budget.
The province is expecting to lose at least half its crop.
In the past 40 years, we've lost over 30% of the world's arable land. The very ground that sustains us is vanishing. But what if the answer lies not on land, but on the edge of it?
For generations, it was believed that coastal farming was nearly impossible. But science tells us otherwise. Clima scientist Robert A. Heinlein said, "Everything is theoretically impossible until it is done." So, we made an attempt to do it. How? One module, many purpose. Innovating agriculture for a better cause.
Project Shorting's multipurpose agricultural module is a transformative solution designed to unlock the potential of coastal areas by offering adaptable and sustainable farming methods. Unlike traditional systems, these modules are built for flexibility, featuring modular components such as HDPE trays and filters that accommodate various agricultural functions based on the specific climate, resources, and needs of each location.
Project Shorting is versatile enough to integrate various functions like hydroponics, aquaculture, salt drying, and food drying, while utilizing a rainwater harvesting mechanism to enhance sustainability. Its multifaceted trait is made possible by being modular.
Aquaculture is possible due to trays being capable enough for aquatic life. Hydroponics is accommodated by designated support components, and lastly, salt drying and food drying are supported due to heat retention and rainfall humidity protection from HDPE covers.
This is more than a project. It's a promise to turn challenges into opportunities, coastlines into lifelines, and hunger into hope. The edge of the land isn't the end of possibility. It's the start of something extraordinary.
That's our fourth team from the Philippines. It's so impressive to see so many amazing finalists from one single country, Marlene. Now we have our very last finalists to show you. They're a team from the University of British Columbia in Copenhagen, in Canada. They're Hacking Challenge 1. They've designed a solar-powered modular farm in a shipping container. It's called Sustaina Container. Let's watch.
Meet the Sustaina Container, our solution to the 2025 World Engineering Hackathon.
When designing the Sustaina Container, we had three main goals in mind. Number one was climate resiliency. Number two was self-sustaining and efficient farming. And number three was it had to be portable. To address these three issues, our final design, we've decided to make the Sustaina Container inside of a storage container. These are highly portable. As you see, they are mainly transported on ships and trains, and they are extremely weather resilient as they are shipped across the ocean in extreme weather.
On the exterior of the container, a bracket has been added to hold the solar panels and a thin battery bank. At max power draw, the solar panels produce 1 kilowatt hour more per day than is needed. You can see the large dehumidifier modeled off the Gen M1 by WaterGen. It is able to pull a maximum of around 16 gallons of water per day. 16 gallons is more than enough water for what is needed inside the container. However, that is only if every system is at max power draw. The Gen M1 can produce up to 58 gallons of clean water daily, making it perfect in a drought.
Through the inner door, we get to the growing area. Each shelf has a drainage system that directs water back to the main tank to minimize waste after filtration. The grow lights copy an ideal day-night cycle, while the HVAC system keeps the room at an ideal temperature and keeps air moving. These features enable year-round crop growth without worry of severe weather damaging or destroying crops. The Sustaina Container is designed to provide a sustainable, modular, and resilient solution to food insecurity, allowing those that experience hunger a secure food source, while minimizing environmental impact through water recycling and renewable energy. The Sustaina Container is a step towards a world with no hunger while in the face of climate change.
Hello everyone. I'm Firas Boudiab, the chair of the World Federation of Engineering Organizations Young Engineers Future Leaders Committee and a member of the World Engineering Day Working Group since 2020. I'm proud to support the hackathon and promote the role and achievements of young engineers around the world.
Hi everybody, my name is Katie Cresswell-Maynard. I'm the Executive Director of Engineers Without Borders International, otherwise known as EWB International. We support the global network of Engineers Without Borders organisations who together represent some 40 countries around the world, where together we mobilise engineering skills and expertise to support people improve their quality of life, particularly those most vulnerable in our society. Alongside that, we also better prepare engineers for the future so that we can together tackle things like climate change, resource depletion, biodiversity reduction, and together tackle one of the biggest challenges of our time, which is alleviating poverty. I like to think of engineering as a bit of an unsung hero in terms of how people live on the planet and how we are able to do all of the things we do every single day. Engineering has had a big role to play. So access to clean water, improved sanitation, the fact that we can rely on transportation systems to get us around so that we can access good quality quality education, healthcare, things like that. So the 3 challenges that we chose for the World Engineering Day Hackathon 2025 are challenges that have the potential to unlock the capability for people to chart their own path out of poverty. So we have our first challenge, which is about improving the climate resilience of subsistence farming. So this is all about Sustainable Development Goal 2, no hunger. There are many parts of the world where agriculture is suffering in terms of lack of access to water for irrigation, perhaps the nutritional value of soils, etc., is degrading. The climate crisis is going to affect food production in quite serious way, whether that's on one end of the spectrum, more severe, more frequent events such as flooding and heavy rainfall, which can wash away topsoil and all the nutrients that you need, or whether at the other end of the spectrum, that's increased instances of drought, so you have no water. And then, when you're thinking further down the food production, how does it get from there to people's plates, for instance? And again, we can be looking at things like the cold supply chain, where you've invested all of this hard work and effort into getting food ready to be eaten, and then as soon as it goes into that distribution, that's where foods can spoil, basically. So this is a really vast area where there's plenty of space for engineering and engineers to tackle any one of those issues and see if they can make a difference. So our second challenge for the hackathon was around addressing some of the issues associated with informal housing and infrastructure. So this relates to SDG 11, sustainable cities and communities. And what we've seen is that as people are migrating to cities, so urban centres, because they're hubs of innovation, they offer the prospect of a better quality of life. Unfortunately, the city infrastructure has not been equipped or can't cope with the influx of people arriving and the rate that people are arriving at. So we end up with what are called informal settlements, and they're often characterized by things like poor quality housing, lack of access to clean water, poor sanitation and waste management. Often it might be land that is prone to flooding, and with the onset of the climate crisis, vulnerability to extreme weather events, for instance, becomes all the more frequent and all the more worrying. So it's a really interesting space for engineers to start thinking about, not just in terms of the kind of hardcore infrastructure and technology, but how the social and environmental and future projected social and environmental aspects of that context are constantly changing. And our third challenge for the World Engineering Day Hackathon really focused on how can technology play a role in empowering women to overcome poverty, with a focus here on digital technologies in particular. There's a lot of research and study out there that shows that if you invest in women in particular, it has not just an impact on those individuals and their quality of life, but it can improve the outlook and the future prosperity of the community as a whole. And so how can engineering play a role in improving women's access to digital technologies? This is a really interesting one because, yes, there's an element about it that's about the hardware side of it. So, bringing internet access. There's a whole host of kit that's associated with that. Obviously, electricity is an important component of that picture. But also there's the I guess what we might call more the software aspect of it. So the apps, for instance, that can be around, healthcare, education, could be focused on specific markets. So there's a lot of financial inclusion tools such as banking, for instance. So there's really like a hardware and a software aspect to this. So it's exciting to see what students are coming up with as a result of thinking about this quite unique and different challenge. So for me, being involved in an initiative like this, the World Engineering Day Hackathon, really brings me a lot of hope and optimism for the future. I am a great believer that engineering has an important role and responsibility to play in addressing the challenges that humanity is facing right now. And so, I have the absolute privilege of seeing all these amazing students from all around the world participate in the hackathon and coming up with some brilliant ideas about how some of these issues and challenges can be addressed. And I'm always overwhelmed and excited and impressed by the quality and the innovation behind the ideas that students come up with. So yeah, it gives me a lot of hope and optimism for the future. And yeah, I'm excited to work with the other judges to identify some of the best ideas that have come forward this year.
Thank you, Engineers Without Borders and the entire team who worked with us tirelessly on this program for us. And thank you also to the WFEO Young Engineers Future Leaders Committee for assisting us in the World Engineering Day Hackathon. And that's it for our World Engineering Day Hackathon final show. Congratulations again to all our finalists. And thank you to all the engineering teams who took part. And thank you to Neil for being my lovely host today. Not only is she my co-host, but Tennille Skitluna and her team from the Big Creative Sydney are the hackathon project leads.
Thank you, Marlene. I'd also just like to thank our co-organisers in crime, Dr. Marlene Kanga, our preliminary and final judges, thank you so much. Our hackathon working group, we couldn't do it without you, the WFEO secretary and everyone in the team, Engineers Without Borders, once again for your vital work and contributions. Without you all, we wouldn't be able to do this very important program. And Marlene, for co-hosting with me today, thank you.
Thank you, Tennille. It's been a privilege and a pleasure.
Thank you. Until next year, guys. Happy World Engineering Day.